Hello all, this is Sandeep Kumar and I welcome you back to my YouTube channel Math with Sandeep. So already in the previous video we have seen how to find the integral part for a given binomial expansion, and we have discussed two examples in the previous video. So this is a continuation of the same concept, okay na, same topic. So here is our fourth question. They told us to find the integral part of 7 plus 5 root 2 whole power 2n plus 1, okay na, fine. Now see here dear students, clearly 5 root 2 is greater than 7, okay, because 5 root 2 is what, root 50, and 7 is root 49. 5 root 2 is greater than 7, so I'll take this expansion as 5 root 2 plus 7 whole power 2n plus 1, okay, and let this expansion is equal to some integer plus fractional part. Let this expansion is equal some integer plus fractional part capital F, where capital F is between 0 and 1. As we have discussed in previous models, capital F is between 0 and 1 and I is a integer, okay na. At the same time, I will take 5 root 2 minus 7 whole power 2n plus 1 is equal to, observe dear students, 5 root 2. Root 2 is approximately 1.414, and then 5 root 2. 5 into 1.414 is how much? 7.07 approximately. 7.07 minus 7 is how much? This value will be 0.07. It is a proper fraction. 0.07 whole power 2n plus 1, where n is a integer, is also a fraction only, proper fraction. Let it be small f, where small f is also between 0 and 1. You should understand that this value is 0.07 approximately, whose power is 2n plus 1, which is also a fraction, some fraction between 0 and 1. Okay now, next we have to decide whether I should add these two or I should subtract. How do we decide it? Obviously, after adding or subtracting, the resultant expansion should not contain any irrational terms, correct or not? So dear students, what if I subtract these two? Let us see. If the irrational terms doesn't get cancelled, then I will add, okay na? So we know that x plus a whole power n minus x minus a whole power n is 2 times sum of the terms in even place, t2 plus t4 plus t6 and so on, and RHS is equal to capital I plus capital F minus small f, because we have subtracted on both sides. So 2 times, the second term is what? 2n plus 1 c1 into the first term power this minus this, that means 2n into second term power 1. Now dear students, please observe, square root has an even power, square root and square will get cancelled. That means what? We have to subtract only. In case if the root is not getting cancelled, then change the sign here, okay na. So anyhow, we can comfortably continue. The fourth term is 2n plus 1 c3 into 5 root 2 power 2n plus 1 minus 3 into 7 power 3 and so on. So in all the terms, root will be cancelled because the power of the root is a even number. And right side we have capital I plus capital F minus small f. We can say that this is an integer plus this is an integer, like that every term is an integer inside the bracket. Integer plus integer plus integer and so on is a integer into 2. So 2 times integer, that is also an integer. So therefore some integer is equal to I plus capital F minus small f. And in the previous problem we have discussed that capital F minus small f will be between minus 1 and plus 1. You can check the previous video to understand this. So therefore, dear students, if LHS is a integer, integer is equal to I is a integer. Integer is equal to integer plus what? Then this must be integer. Integer is equal to integer plus integer. So capital F minus small f is an integer na. The only integer between minus 1 and plus 1 is 0. So therefore, I will write the LHS as what? 2 into something. 2 into k, where k is a integer. Okay, I write LHS as 2 into some integer. So 2k is equal to I plus capital F minus small f is 0. Therefore, I is equal to 2k. The integral part for this expansion is equal to I plus f na. Its integral part is 2k. That means even number. So, therefore, the question is what? Integral part of this expansion is what number? Even number. Option A is correct. Right? We'll go with the next question. Here is our next question. They told us to find the integral part of root 2 plus 1 whole power 6. What is the integral part? And particularly they have given numbers. So please observe, dear students, how to find it. Okay. So first, so let root 2 plus 1 whole power 6 is equal to capital I plus capital F, where I is a natural number or an integer and capital F is between 0 and 1. Capital F is between 0 and 1. It is a fraction. So I can always write this number as integer plus fraction. Correct or not? Next, we can take root 2 minus 1 whole power 6. So if you observe, root 2 is approximately 1.414. 1.414 minus 1 is 0.414, which is a proper fraction. 0.4 whole power 6 is also some fraction between 0 and 1. Now we have to decide whether I have to add these two expansions or subtract. You can check with both. I already know that I have to add these two expansions, because when I add, then only the irrational terms are getting cancelled. So when I add these two expansions, we know that it is 2 times sum of the terms in odd place. And right side I plus capital F plus small f. So 2 times. The first term is what? 6c naught into root 2 power 6 minus 0 and into 1 power is not needed, no? Plus. The third term is 6c2 root 2 power 6 minus 2 into 1 power 2 not needed. The fifth term is 6c4 into root 2 power 6 minus 4 is 2 into 1 power is not needed. And finally 6c6. Here we have limited number of terms. 6c6 root 2 power 6 minus 6, which is 0 into 1 power is not needed. Close the bracket. It is equal to I plus, and we have already discussed that capital F plus small f is between 0 and 2, and the only integer between 0 and 2 is 1. So capital F plus small f is equal to 1. Okay now. So we have discussed this already. Capital F plus small f is equal to 1. If you want more clarity, then check the previous video. So 2 times this value will be root 2 power 6, which is 8. This is 2 and 1 second, it is not 2, it is 4. Correct or not? 4 into 6c2. What is 6c2 value? 6 into 5 divided by 2, you will get 15. 15 into 4 plus 64 is also 15 only into 2 plus 66 is 1 into this is also 1. So therefore, dear students, LHS value is what? This is 60, 30, 90, 90 plus 9, 99. 99 2s are is 198 is equal to I plus 1. Therefore, I is equal to 197. The integral part of root 2 plus 1 whole power 6 is 197. It is option B. I hope it's easy for you. We'll go with the next question. Here is a question. Let 5 plus 2 root 6 whole power n is equal to p plus f. And what is p here? P is a natural number. That means p is the integral part of this particular expansion. And f is between 0 and 1. That means f is the fractional part. Then they are asking us to find the value of this. Easy question only, dear students. Easy question only. So come back to this. Let us see how to find the value of it. Okay now. So first of all, 5 plus 2 root 6 whole power n is equal to p plus f. And we can take 5 minus 2 root 6 whole power n, because this is larger and this is smaller. Okay, 5 minus 2 root 6 whole power n is equal to, I will take capital F. Here f is between 0 and 1 and capital F is between 0 and 1. So I am going to add these two expansions. Let us see what happens if I add. When I add and if irrational terms are not getting cancelled, then I have to subtract. Okay now, fine. If I add, I will get 2 times first term plus third term plus fifth term and so on. and right side I'll get p plus small f plus capital F. Okay, so 2 times. The first term is what? nc naught 5 power n plus the third term is nc2 5 power n minus 2 into 2 root 6 whole power 2. Please observe, dear students, the root is getting cancelled. Yes, that means we have to add here. Plus nc4 5 power n minus 4 into 2 root 6 whole power 4 and so on is equal to, the right side is p plus, this is going to be 1. Already in previous examples we have discussed. Check the previous video for more clarity, right? And left hand side, if you observe, it is 2 into integer plus integer plus integer and so on will be an integer. So 2 times k, this entire thing is taken as some integer called k. So k belongs to z. 2k is equal to p plus 1. So therefore p is equal to 2k minus 1. Okay, fine. P is a odd integer, but they are not asking about the value of p. You just understand that p is an odd integer. Okay, fine. Next, p is an odd integer, but that is not what they are asking. Then what to do in this particular question? Let us multiply these two expansions. If I multiply these two expansions, 5 plus 2 root 6 whole power n into 5 minus 2 root 6 whole power n is equal to p plus small f into capital F. Right? We can use a plus b into a minus b, a square minus b square, again whole power n is equal to p plus small f as it is. And we know that, dear students, small f plus capital F is between 0 and 2, and the only integer between 0 and 2 is 1. You already know that why we are taking small f plus capital F is equal to 1. So check the previous videos if you have no clarity about that. Now from this we can say that capital F is equal to 1 minus small f. From here we can say that capital F is equal to 1 minus small f. So instead of capital F, I'll write 1 minus small f. Expand this. P into 1 is p minus pf plus f minus f square. And left hand side 25 minus 24. 25 minus 24 is 1. 1 power n is 1. They are asking us to find plus pf minus p and then minus f and plus f square. That means multiply with minus on both sides. Minus 1 is equal to plus pf, what is it, plus f square, and then minus f, and then plus pf, and then minus p. So this is what they are asking. What is the value of it? It is minus 1. Okay, now so remember, this is important. We have to decide whether we have to add or subtract. So then only we will know whether we have to take small f plus capital F or small f minus capital F. All these things. Check all the previous videos. You'll get more clarity. I will give you one more question. You can try it yourself. Here is the question on the board, dear students. You can pause the video and you can solve this particular question. And remember, this is not a single correct option type. This is one or more than one correct type. One or more than one. This is one or more than one correct type question. Okay, na? So one option can be correct or more than one option can be correct. So do solve it and check whether you got the answer or not. In case if you have got the correct options, then it means that you have understood this model very much clearly. Yes, so that's it, dear student. That's it about the problems on integral part of a given binomial expansion. Okay, so I hope you have understood this particular concept. If you felt like the explanation is really useful, then do share this video to your friends and do subscribe the channel if you are new to our channel. Share it with your friends, and I'm also present in other platforms. The same username, math with Sandeep. So you can find me in Instagram, Facebook, Threads, and at the same time Twitter with this particular name, math with Sandeep. And I will be posting all the notes of the concepts that I'm explaining in this particular videos in those channels. And at the same time I'll be explaining the previous year model questions and important model questions, difficult model questions. All these will be there. All this will be posted in those platforms, in those pages. So do follow me in Instagram, Facebook, or Twitter, or Threads, wherever it is. And do comment if there is something that you want me to know about. and see you all in the next video.